Hey everyone, my name is Luke Herrington. I am a senior JavaScript engineer at 4 Kitchens. We're a digital agency and we make big websites. It's actually my work on NBC.com and the apps that inspired this talk, the API work. And the talk is components as data, a cross-platform GraphQL-powered component API. And if that's not a mouthful, we're going to unpack it, don't worry. I just threw a bunch of buzzwords in there to get you all to come. Right? So let's start with components. Components are these things that show up in our front ends, and everyone across our industry is using them to build UIs. They're the fundamental building blocks of a UI. Doesn't matter what framework, what platform you're building on, you're using components to build it most likely. So I think components win. We've found a really good abstraction for building UI. But what is a component? So I like to define components this way. This is kind of like pseudo math here. A component is a function of rendering props and state. And those words might sound familiar to you if you've built a React app. Let's dig into those words a little bit more. So props I think of as read-only external data. They're basically the parameters to your render function. State is going to be local data that changes over time. And your render is a declarative representation of the UI based upon the current props and state. So let's start with just this simple example of a component, and then we'll get on to the API stuff. So here we have a switch component. This switch component has a label. It has some state, whether or not it's on or off. And it has some presentation to it. You know, when it's on, it's green. When it's off. So the thing about components is that they're also composable. So we could take this switch component, and we could add it to a row, for example. And say we take that row component, and we add it to our settings screen, and suddenly we have basically a screen in our application. So I love components. As a 90s kid who grew up building Legos, I can't help but love them. They feel like Legos. And they're genuinely fun to work with. And we see this happening in our industry. Like, it doesn't matter if you're building something with Swift UI or Flutter or React Native, Vue, you're using this general abstraction. And I think it's because it's a good one. So I'm going to stop gushing about components now because this is also an API talk. And you're thinking, OK, where do we get to this whole GraphQL thing, right? So, but I just love components so much. I'm just going to leave this slide up for a second. No. Let's move on. So when you get into building an application, there's these pieces to your app, to your architecture. And I'm going to use this throughout the talk to kind of describe this API approach. So generally, you're going to have some sort of database or data store. You're going to have business logic, which describes the rules that your business wants to accomplish and help the user. You're going to have some data fetching with some third-party or external APIs, and you're going to be denormalizing your data from your database with maybe some third-party or other API data. And you're probably going to have some sort of feature flagging, A/B testing, and then, of course, you're going to have some sort of component library, and you're going to kind of stitch that all together in a composable way into the pieces and the pages or screens for your application. So you can combine these things in countless ways, and it's basically our job to figure out how do we put these together. And as you're building these things, usually there comes a point in the conversation when you're architecting an application of, OK, are we going to take kind of like a more monolithic approach, or are we going to decouple and build an API? So when you're decoupling, we've had these kind of conversations before. Who should use like a decoupled architecture? What is decoupling? Let's define the terms. When should you do that in a project lifecycle? Why? Why is it a good idea? Why is it a bad idea and sometimes? And how? The how-to. But one that we generally neglect, and I don't think it's on purpose, but I think it's because it's assumed, is where. Where do we decouple our applications? So in this talk, we're going to use our friend, the Decouple Line, to kind of describe and explore this question of where do you decouple your application. So as the Decouple Line moves around your architecture, some really interesting features of your API are exposed. The format of your API is exposed, and the content of your API is different. So let's start by describing a typical decoupled architecture. This is one that I think is basically assumed in general when we build APIs for our apps. And that is that you basically decouple right before business logic, but right after the data store. And essentially, you're building an API that exposes the raw data of your data store, your database. And this API is going to have listing functionality. It's going to have filtering functionality, sorting, including or joining of some sort. It's pretty typical. And a good example of this approach is the JSON API spec, which is an API format specification. In this format, you're going to roughly map CRUD operations to HTTP verbs. And the queries are going to look pretty atomic and low level and almost like a SQL query, where you're basically saying, give me the authors, and you better know there's an authors table somewhere in your database. And I want to get the posts for those authors, and there's probably a post table. And you can see what I mean by kind of it being pretty closely mapping to your data model. So I think this is what people usually mean when they say that their API is RESTful. And let's be real, no one really knows what that means except for our fearless leader, Roy Fielding. But let's look back here. This leaves, if you look kind of on the other side of the decouple line, this leaves a lot for API consumers to implement. This leaves them with business logic, further API fetching and denormalization, A/B testing, and the whole gamut. So let's move this line over a bit to here. So in this approach, you're exposing business logic in your API. And this is a really common approach for product companies. You're still exposing the resources of your data store, but you're also exposing operations upon that data. This is, it's more than just resources or entities that you're exposing. A great example of something like this is Stripe's API. Stripe is a payment as a service company. And they expose a really, really powerful API for working with things like charges and customers and subscriptions, right? But you're not just simply going and getting a subscriber and then deleting a subscriber. Stripe also exposes parts of their business logic in the API. So you could dispute a charge. What HTTP verb does that map to? Not really any. And these kind of APIs can get very powerful. They're essentially exposing their business logic to you. And most of their customers are going to be developers that need someone else to deal with the hard bits of payments, for example. So this format and the prior get really powerful when you introduce something like HATEOAS. HATEOAS stands for Hypermedia as an engine of application state. Another mouthful there. So let me give you a basic example of what HATEOAS looks like in action. And this is a very basic example, in my opinion. I think pagination of resources in your API is an example of HATEOAS. So imagine that we have this listing API where we're going to get a list of things, and below our data, we're going to return this kind of like metadata attribute in our response called links. And the links are going to include these things like self, next, previous, last, first. So if these links exist, the UI can know that there's more to see or that there's something else before this page of the list. So what they can do is wire up their UI to, based upon the existence of one of these properties, create a next button or a previous button. And in that way, the server is powering the state. We could do things like calculating the last page by dividing the total count of the number of items in this list by the page size. If some links don't exist, then you just simply don't create the UI for that. And the other really powerful thing about HATEOAS and Hypermedia is that you can swap out the implementation without front ends even knowing. So in this example, I've switched to an offset-based pager. You can do the same for a cursor-based pager. And because the front ends are basically grabbing this link and running a GET request on it, they know no difference. Super powerful. Imagine doing that for your users. If you work on a SaaS and you expose an API, you're not only exposing this really helpful business logic, but then on top of that, you're exposing all of these actions and operations that they could basically generate and machine read and work with. So there's kind of the explanation for this architecture. So let's move the line all the way over to this other side. And this one's a bit of a stretch, I'll admit it. It's not really an API anymore. You're basically building a monolith where you're sending HTML, CSS, JavaScript down the wire. But it's a decision to make nonetheless when you're choosing your application. And I want to kind of address the elephant in the room here, that the word monolith has become this low-grade insult in our industry. And I think that's a shame. I think it's a case of guilt by association. There's folks in our industry that have been in the industry for a long time and worked on these large code bases, or joined a team as a new member and had this legacy, quote-unquote, application that was really difficult to work with, or maybe it was poorly designed, and it also happened to be a monolith because that's how everything was built for a very long time. But just because the different pieces of the application don't communicate over the network doesn't mean that the app is poorly written. In fact, I would argue the opposite. You could take a poorly written monolith and break it up into microservices, and now you have two problems. You have a poorly designed application that communicates over the network, and you have cap theorem to deal with now, and consistency and concurrency issues. So don't go so hard on the monolith. I think it's a pretty good pattern. Monolith does not mean spaghetti code. Okay, so let's move on to the next. This one's interesting. What is an application whose database lives in the client? Well, it's an offline first application, or it's a local first application. And I'm really excited about this kind of pattern right here these days. In a world where people and their data, their private data, has become a product, this pattern, I think, could be really helpful. Okay, I'll get off my soapbox. There's some really interesting research happening in distributed, local first, offline first applications. It's a hard problem. So you have an app that has been offline for 2 weeks and connects to the network and needs to sync with others, with other nodes in the network. How do you solve that problem? That's it's a hard problem to solve. But it's a real problem. If you have a customer who's going to be out in the field for 2 weeks or in low latency and no internet connection, this might be an API that you consider building. And it kind of takes the form of syncing. There's some really interesting research happening in this spot with CRDTs, which stand for commutative replicated data types, wherein you essentially model the operations on your data as commutative so that you can basically not worry about the order in which operations happen when you reconnect to the network. Really excited about this pattern, and I think more apps should be built with data privacy in mind, data ownership. Okay, so finally, let's move to components as data. In components as data, the backend has essentially absorbed a lot more work, but leaves something for the front ends to do. And at this point, the backend kind of becomes a front end in its own right. So what this looks like is an API that serves JSON, structured in terms of a UI tree. And if that sounds confusing, we're going to unpack it and get some examples here. So your components can be described as data, hence the name components as data. So let's get to an example. Here's the most basic example I could think of, a hero component. So here we have a JSON blob with a field called component. That component field is going to map directly to a component in your component library. And then you have the data. And the data is essentially going to represent the props that are needed to render that component. Any state that the component might have is going to be locally handled. So I wanted to address another thing. When React was first released, there was this big conversation that happened about separation of concerns. In the creators of React's mind, I think there was this ability to question best practices, and I'm glad they did it. But then also, with the introduction of hooks, which is a way of abstracting logic out of components, and suspense, which is going to solve for data fetching and a couple other problems, I think we've seen that the component as an abstraction isn't necessarily the best abstraction for expressing business logic or data fetching. So I think that this pattern kind of works with that a little bit. So this is a scary part in the talk where I need to load an iframe. Oh my gosh, it worked. Okay. Whew. So we used this pattern to build out NBC.com and all of its apps, Android, iOS, Roku, and the TV app Samsung Vizio. So across platforms, we've used this components as data to basically render this slideshow here, some shelves with your favorite shows. This Is Us. Any This Is Us fans out there? Okay. All right. How about Will and Grace? It's the 90s? Yeah, okay. So we use this pattern at NBC. We started out kind of about right here with a very data model-centric API, exposing the raw data with very flexible and powerful filtering, sorting, including and joining kinds of logic. This left a lot for the front ends to do, and they were all re-implementing basically the same queries with basically the same business logic and having to deal with all sorts of denormalization on their sides and A/B tests. They were all doing similar A/B tests, and it just didn't seem dry when ultimately we wanted a consistent experience across platforms. So we moved the Decouple line over a bit, and we kind of built this proxy of sorts, where we're including and denormalizing data from multiple sources, multiple APIs, and giving the clients much more to work with and much less responsibility. But then as we built this out, we found that what the business wanted was a very powerful suite of A/B testing and very quick cross-platform A/B testing and feature flagging. And re-implementing that across platforms was more work than it needed to be. So what we did was we moved towards components as data, where we absorbed that work, and we absorbed the component library into the back end. So some basic components that live in the MVC data model would be, a slideshow that contains slides, a shelf that might contain a series tile or a video tile. So those are what we're going to be working with our examples here. It's a very basic example. So we chose GraphQL to implement this pattern. And I think the reason we ultimately did it was because of the types and the queries. The coupling of the queries and the types in GraphQL is a perfect match, in my opinion. The way that these types need to be shared, especially in the component library as data, it was just really powerful to be able to describe those with GraphQL schema. And we'll show some benefits of doing that. So let's just do a quick overview of what the GraphQL schema looks like for an application like this. And this is, again, a simplified example. So we're going to have an interface called component with a component field like we talked about earlier, and a treatment field. And this treatment field was essentially our quasi-class name field that works cross-platform. So if we wanted a component to be, the primary or the featured type of component, we didn't have to create a whole new component for that. We could kind of just augment it with this treatment field, like a class. Then we have our video tile, and the video tile also has a component and treatment field, and it's going to have a data field like we talked about. And that data field will contain like an image, title, secondary title, and percent viewed. We decoupled the data from the component for reuse if another component type might need video data. So then we have our shelf, and a shelf is going to contain tiles. So we define a series tile in a similar manner, and we union the video tile and series tile together into this tile union. And the shelf data, the data for the shelf, is going to contain this items field, which is basically a slot for tiles to live. It's kind of like children, but it's more specifically kind of tied to like a slot of components. So we're going to introduce this new interface called section, right? And you'll see why in a bit, but this section interface is going to kind of delineate a shelf component from other types of components. It's a component, but it's also a section. Same goes for featured. Slideshow is a different type of component. It's like a featured component, right? And these things might have different properties, different analytics information and metadata information. So introducing a new interface makes sense. So a slideshow contains slides. I think we get the picture there. And then finally, we're going to have our page type. The page type stitches this all together. It takes a featured field, which is going to be, like that slideshow up at the top on the home page as the example. And then the sections field, which is going to essentially represent all of the shelves in the UI. And then our query will take the name, user ID for personalization, and a platform so that we can vary this on platform. So let's give another example. This is what it's going to look like in Apollo Playground. So here we have our home page. We're using our page field. We're querying the home page for user ID Luke on platform web. And you can see here that we're spreading our slideshow fragment into featured, shelf into sections. And as we build out more and more components that are of the sections interface, we would add more, like a group or other types. So here we have our fragments that are going to look as you would expect. And this is what it looks like to send back a UI tree as JSON. We have our page with our featured section and our sections array. And we have our component called slideshow with items of slides. And sections are going to contain our shelf. And in this case, we have a top picks for you shelf that returns a bunch of series tiles, personalized just for you. Let's show another example. You don't have to just build out pages this way. There's nothing that is forcing you to build out an entire page response. You could build out certain features. So when I talked about absorbing the business logic, this is kind of what I meant. One of the features of NBC.com, or really any media streaming kind of platform, is some sort of continue watching feature, where you can pick up where you left off on the videos that you've been watching. So here we've exposed a continue watching field that just returns the continue watching shelf. A bunch of video tiles with some percent viewed, some images, and the UI is going to map over this field and generically render its contents. So let's talk about this. I think that what we're describing here is some sort of design schema, where your component library is described in terms of GraphQL, in terms of a schema. And this is, I think, what we are trying to accomplish often when we build a design system, is we want rules, we want structure. And this type system ensures that. A great example of this is when you throw in the schema into an open source tool like GraphQL Voyager, and you can see kind of this component library described as a graph. So let's look at page, which is going to contain featured and sections. So we'll go to sections where there's a shelf, data, there's our tile union, and then a tile could be a video tile or a series tile with their respective data. So what does it look like to actually implement this on the front end? We showed kind of the back end implementation, and we're going to use React to implement this. So we'll start with our component library. That's how most front end projects begin. And we'll build out a slideshow. A slideshow is going to have some state as to which slide it's currently on, a slide number, and it's going to receive props. And remember that the props here is the data that comes from the API. So it's going to include this items field. So we can map over the items field and get slides. And we're going to generically render the children using this dictionary, passing the data through and the current state of the slide number. Here's a boring slide component. These are just example snippets here. So these dictionaries are where kind of the magic happens here. These dictionaries map to the interfaces in our schema. So you remember our featured interface and our sections interface. So we add the respective components from our components library into these dictionaries. Then when we want to go render a component, we use the respective dictionary, we grab the component field, look up the component in the dictionary, and generically render it with its data. Finally, here's an example of how we could stitch together that full page query that I showed you, where we're using the featured section with the featured dictionary, grabbing out the featured property, and then rendering our sections array and mapping over the sections and rendering whatever component we have. So this is, I think, a pretty interesting solution to a hard problem that that NBC had. And maybe you have it too. Here's some of the hard parts. When business logic gets fragmented and you're centralizing the business logic, you have to deal with it in a centralized way. And that can mean bloat. and something you tried to dry out, if you've ever tried to dry out some code with don't repeat yourself, and then turned out, oh, actually, I kind of want to repeat myself, you know that pain. The same goes for variance across platforms. If iOS wants this slight tweak and Android wants that slight tweak, there can be variance in the design or the components that get sent down or the order of the sections, right? So handling variance was an interesting problem that we had to solve. And we solved those by creating this abstraction that we called the conditional resolver. And you saw, maybe if you were here in the last talk, what a resolver looks like. And the conditional resolver allows you to essentially compose an array of resolvers together with some basic conditions that are going to be looking at the args off of your query, the variables off of your query, and the context as well, and choosing a resolver to run based upon the current context. Another interesting problem was pagination and lazy loading. But we solved this by just creating another component called lazy shelf. So we created a lazy shelf that tells the front end, hey, when you render this thing, there's not really much to do, but we were able to tell them, hey, implement it like this. When you get a lazy shelf, use this query that we're going to give you the query name in the lazy shelf data, and then use these variables that we're passing to you. And when you render, make this call. And when you get the callback in the response, you'll get a component, and just swap it out. So if you get a lazy shelf, you render it, it goes and fires off a request and returns a shelf, and then you just swap in the shelf. There's some good parts, too. This led to vastly simpler front ends. It's a different problem set for them to solve. It's not easy, don't get me wrong, but it's simpler. We're also able to centralize business logic, which has a lot of pros, less fragmentation and differences across platforms. Also, centralizing A/B tests and feature flagging has been a huge boon. Being able to roll out an A/B test across platforms with no front-end changes is almost like magic. Same goes for feature flagging and releases. We also get this design consistency with a design schema. The documentation of your component library for a front end is described in the schema, and you can use all these really interesting GraphQL tools out there to document it. And finally, on the server side, we were able to do some query optimization and caching that you just simply wouldn't have been able to do on the front end. So here's what I'll leave you with. I'm not saying that everyone should use this pattern. In fact, I would caution you against it if you have a very transactional-heavy app, or if you have a UI that is very form-based, or I think you get what I'm saying. If you're serving content or media and you need to be very swift in A/B tests, and you're doing that across platforms, this might be a good fit for you. It's not for everyone, though. And I guess what I'm leaving you with is when you're going to design an API, think outside the box. You never know what you might come up with, and you can have some fun doing it as well. Thanks, everyone, for having me. It's been an honor speaking here. Thank you to the conference organizers, and come talk to me afterwards.